How do we sketch trigonometric graph? A simple approach discussed in details by Anil Kumar. Enjoy the journey of learning. Thank you. I am Anil Kumar. Welcome to our YouTube channel. Here you can find thousands of videos absolutely free, which can be very useful for you. In this particular video, we are discussing how do we sketch graph of a transform tangent function. You can explore the playlist to understand graphs of other trigonometric functions. We are given f of x equals to minus 5 over 3 tan of 2x plus pi by 2 minus 8 by 3. Now, if you understand this particular graph, you will be able to sketch almost every tangent related graphs. We'll begin from the very basics, go step by step. I'll show you how do we sketch this graph with the points and without the points. So overall, we know it is a transform tan function. So what we can do here is write down the 5 key elements for tan theta, or we can say tan x. Now the important thing here is that tangent functions have period of pi, right? So we have a vertical asymptote at x equals to minus pi by 2 and at plus pi by 2, right? It's an odd function, symmetric about the origin. And the two key points which we have considered as vertical asymptotes. The other three, which includes coordinate points, which are it goes through the origin, so 0, 0, and at pi by 2, the value is 1, and at minus pi by 2, the value is minus 1. Correct. So these are the key points which you see in a tan function. If I have to sketch it, let me draw a sketch of tan function here. It is always increasing, right? So these are the two vertical asymptotes which we are talking about. Periodic with a period of pi means from minus pi by 2 to plus pi by 2 is pi, correct? So it repeats. The graph is always increasing. Let me sketch it like this. It goes like this, right? And the key points which we are considering is it goes through origin, and there these are the three key points. So at pi by 4, the value is 1, and at minus pi by 4, the value is minus 1. Clear? So that is your parent function. Now let's look into what do we expect after transformation of this particular graph of f of x. So first thing I will recommend is always rewrite this function. So we'll rewrite this as f of x equals to minus 5 by 3 tan factor out 2, right? So you get the right translation. So when you factor out 2, you get x plus pi by 4 minus 8 by 3. Now you see that the vertical values are stretched by a factor of 5 by 3 reflected because of this minus translated 8 by 3 down. So we have seen a couple of things for vertical transformations. As far as the horizontal transformation is concerned, we have a horizontal compression by a factor of half and translation of pi by 4 to the left. So in short, I can say that any coordinate point xy on the parent function will now get transformed where the x values horizontally compressed means half of x, translated left by pi by 4. So that happens to the x values. The y values, they get multiplied by minus 5 over 3, right? And then shifted down by 8 by 3. So that should give you the transform points. Is that clear to you, right? Now, directly we can write down what will be the values for these transform points. What happens to the vertical asymptotes? Now, vertical asymptotes are key in sketching the graph of tangent functions because they give you kind of a boundary for one particular wave. I hope it makes sense, right? So, here we see that instead of minus and plus pi by 2, we are compressing it so it becomes minus and plus pi by 4, and then we are adding minus pi by 4. You get the whole idea, right? So the vertical asymptotes will now be, so if it is minus pi by 2, right, we get it multiplied by half, and then we do minus pi by 4, correct? So what really happens, as you can see here, is that when you multiply, it is minus pi by 4 minus pi by 4. So minus 2 pi by 4, correct? So the vertical actually shifts to the value which is minus 2 pi by 4 or minus pi by 2, correct? The other one, let me use another ring, which is plus pi by 2, right? Multiply by half, take away pi by 4, will give you what? So this is pi by 4 minus pi by 4 is 0. That means that we have our vertical asymptotes. Let me redraw here, right? And these vertical asymptotes now are at minus pi by 4 and at 0. You understand? So it has shifted left. I'm not drawing the vertical axis here because we'll calculate the vertical points and then rewrite them. We also notice that there is a reflection, means the graph basically will be moving downwards, right? Instead of rising, it will be falling like a cotangent function. You see that point? So we are expecting that our function f of x will be always decreasing as shown here, and one wave will be from minus pi by 4 to 0. That means there is a period of pi by 4. Makes sense, right? Now we need to find these points, correct? And you can easily calculate 0, 0. When you consider, in that case, the transformation will be minus pi by 4 minus 8 by 3. Right? So this point here is minus pi by 4 minus 8 by 3. You see that? So we calculated the center point. The other 2 points you need to calculate. So plug in the value of x, which is pi by 2, right? So you get pi by 4 minus pi by 4, which will be 0 for you, correct? So the y value which you are going to get is, so x and y values you can calculate from here, right? So I like you to calculate these points. Is that okay? Once you calculate, you have accurate graph right there for you. But I've already shown you how it is going to look like. Makes sense? Now, next thing which we are going to figure out is how do we find the scale on the graph? That is another very key part. Since we have a vertical stretch by 5 by 3 and a translation of 8 by 3, that means our vertical scale should be divided into 1/3. So let's look into that part now. So here, what I've done here is that we have one unit here, right? One, and each unit here is 1/3. 2 by 3, and this is 1. You see the vertical scale? Every division has been divided into 1/3 so that we could sketch 8 by 3, right? Because we have to shift the whole graph 8 by 3 units down. So now I think the scale is clear to you. Since the translation was pi by 4, we have pi by 4 here. Do you see this pi by 4 plus and pi by 4 minus? Now, we know that the vertical asymptotes are at minus pi by 2 and 0. So, I could draw the vertical asymptotes here. I'm only sketching one graph. We know this is periodic, right? Periodic with pi by 2 as the period. So that will be the second, third wave which you can continue. Is that clear to you, right? So our focus will be in sketching only one of them. Now let's rewrite this particular function as we wrote as minus 5 by 3 tan of 2 common x plus pi by 4 minus 8 by 3. So clearly 8 by 3 is the axis, right? So the center line, which is at pi by 4, is symmetric, right? We are looking at 8 by 3. So what is 8 by 3? 8 by 3 is basically 3 times 2 is 6 and then 2 by 3. So 2 full, right? So it is 1, 2, right? And then 2 thirds, 1, 2. So that becomes minus 8 by 3. You get the whole idea? Minus 8 by 3. So that is the y value. Correct? I should write here. Correct? So minus 8 by 3. So that is one of our points. The other points, instead of 1, we are multiplying by minus 5 by 3 and adding minus 8 by 3. So the transformations, let's rewrite once again. X, y values were changed to, the x values became half and minus pi by 4, correct? The y values got multiplied by minus 5 by 3 and subtract 8 by 3. Well, we do have the center point. Now for plus and minus 1, we can calculate, right? So if I have pi by 2 and 1 here, sorry, pi by 4 and 1 in the original function, in that case, if I multiply by half, it becomes what? Half times pi by 4, right? Minus pi by 4. And the y values get multiplied with 1 means minus 5 by 3 minus 8 by 3. Correct? So let's calculate. So it is pi by 8 minus pi by 4, which gives you minus pi by 8, right? So we get minus pi by 8. And the y value becomes minus 8 and 5, 13, right? Minus 13 by 3. You see this point, right? So the graph is clearly at minus, which is right there in between. This is pi by 4 for us, right? This is minus pi by 2, right? This is minus pi by 4. So pi by 8 is right there in the center, correct? And we have to go down minus 13. This is 8, 9, 10, 11, 12, 13, right? So we get our point here. So minus 13 means 3 times 4 is 12. So 4 full units and then 1/3. You see, we got our point here, right? That is this point. So the point which was at pi by 4, 1, now is reflected down. And we have it right there, right? Similarly, the other point, because we know it is 5 by 3 up. So we can go 5 by 3, 1, 2, 3, 4, 5, correct? And we get this point right there in the center. So the other point you can also calculate, which will be for minus pi by 4 minus 1. Let me write in green. Minus 1, right? So when you calculate this point will be at minus 3 pi by 8, and the value is minus 1, correct? Which is the point right here. And you can connect these graphs, imagine, because this is the center point, and it will go like this. Does it make sense to you? So putting the vertical asymptotes as shown here at origin and at minus pi by 2, with the curve like a cotangent function always decreasing, and the transform points as shown, we get our graph. Is that clear to you? So we also shown you in parts how do we calculate each and every value, how it gets transformed. I hope this concept is absolutely clear, right? So so here is your calculated values shown in form of a table here. You can actually look into these, correct? The complete calculation which I showed you. How do we get this is shown here. Perfect. And then that is your final graph as it looks like from a graphing calculator or a graphing software. Just as we had shown, that is the center point 0, 0 transformed to minus 8 pi by 3, minus 8 by 3 the y value at minus pi by 4. And the two vertical asymptotes, one at minus pi by 2, the other one at 0, which repeats, you can see, correct? And your graph repeats as shown here. So finally, we have three cycles of the same graph. So once you draw it, it will look exactly like this. The orange lines shown here are horizontal translation of minus 8 by 3, and from there moving 5 by 3 up and 5 by 3 down. So that's a very easy way of getting these points, right? So this point is minus 8 by 3. This point here is minus 8 by 3 plus 5 by 3, and this is minus 8 by 3 minus 5 by 3. You get the idea, right? Very easy calculations. And this is minus 1, and that one is minus 13 by 3, correct? So you get these three very easy points if you do simple calculations. Once you get the vertical asymptotes, midpoint, which in this case will be pi by 4 minus, becomes kind of the center axis of symmetry for this tangent graph, always decreasing. I hope it makes sense. Feel free to write a comment, share your views. If you like and subscribe to my videos, it'd be great. Watch some more from this playlist to understand in details how do we graph trigonometric functions. Thanks for your valuable time and all the best.